Yes, is it audible now? Jobita, Shaima, Sabiha, and Zainab, and Jesslyn. Jesslyn is audible.
Yes, ma'am.
Is it audible? Okay. So see, did you try the question? I think I've given 5 minutes for this question. Any answers? I didn't receive any answer. See, how do we solve this question? One thing I have already written. What do you have to find out in this question? So it says that from a disk of radius r and mass m, a circular portion of r by 2 is taken. Now you have to calculate the center of mass of the remaining portion. So it was a bigger disk, a smaller disk has been taken. So this crescent shape is left. This center of mass you have to find. So one way which is very nice is that take the original disk, subtract the disk of radius. R by 2 means center of mass of this minus center of mass of this will give you. But in this question, we'll be doing it in this manner also, but you have to find out certain things. But before we do that, one formula is there, but your marks might be reduced in that because you have not shown the steps. That's why we'll be following it in detail. It's the same formula. So whenever you're using the formula, your marks can be cut. So for that purpose, what you have to do, you have to mention the variables. Firstly, you have to mention this, that you're calculating the original disk of radius r minus the disk of radius r by 2. And then when you will write it, then your marks won't be cut. And you have to mention each and everything. What is M1? What is X1? What is M2 of this is an important formula because it will help solve all the questions. So remaining is M1 X1 now minus M2 X2 because that's what we are doing. And when you take the common, so it is M1 plus M2. Now the problem is that you know the mass of the disk, complete disk, that is capital M. So how to find out the mass of the one? How to find out the mass of the disk with radius r by 2? That's the question. Capital R square. This is capital M. So mass of unit area. Mass of unit area will be M by pi r square. So for pi r square is the mass for area of radius pi r square, you have the mass as m. Which radius do we need? We need it for r by 2. So put it. If we need it for r by 2, so it will be mass of pi r by 2 whole square will be. Unit area is m by pi r square. So for pi r by 2 whole square, it will be m by pi r square into pi r square by 4. So r square will be cancelled, pi will be cancelled. So what is the mass that you're getting? This mass is m by 4. So what all things do we have? See, mass 1 is m. Separation is 0. Why? Because the reference line by 4. And what is its separation? It's r by. Now you can put it in this formula m1 x1 minus. For the mass of the radiation, m plus it's m by 4 into r divided by not r by 2 divided by m plus m by 4. Calculate and tell me what's the answer. Okay, the voice is lagging. Wait. See class, how have we solved this question? Let me know if the voice is lagging again. We have a bigger disk. We have to cut a smaller portion of r by 2. So this is the formula m1x1 minus m2x2 divided by m1 plus m2. Now, mass of pi r square is m. Mass of the unit area is, yes, I am explaining it again, Zainab. So mass of pi r square. What is pi r square? Pi r square is the complete bigger disk. So its area, this is pi r square. So mass of this is capital M. So for unit area, it will be m by pi r square. Now we require that small disk which has the radius as r by 2. So its mass will be pi r by 2 whole square. So for unit area, it's m by pi r square. So for pi r by 2 whole square, it will be multiply both of these. So when you multiply, you will be left with m by 4. Now see, we always choose a reference line. So let's say at the 0, this is our reference line. So for capital M, bigger mass, this is exactly at the this origin 0, 0. It is the origin 0, 0. So that's why first mass is M, x1 is 0. M2, we have calculated the mass of this leftover portion. This is m by 4 and its separation is r by 2. So m by 4, r by 2. So once you put it in this formula, see what are you getting? See, in this question, when you are solving this, this is m into r by 8. This is m into r divided by 8 divided by, this is 5m by 4, right? This is what is given. So mass will be cancelled. So we are left with r by 8. Okay. And this is so 4 by 5. So this is your answer. 4. This is 2. So r by 10. So this is r by 10. That will be the center of mass. Now write it. If you have any queries, how 5m? Zainab, this is m plus m by 4. So 4m, when you take the LCM, how do you take the LCM? It's 4m plus m, so which is equal to 5m by 4. Mass will be cancelled. So 4 will go up, 5 will come down. Now it's clear. This, we have taken the LCM here. This you should know how to solve it yourself. Though I have solved it, I wanted you all to give the answer. But this is how you have to solve. Tell me, it's clear to all of you?
Yes, ma'am.
Okay, now write it. See, first mass when you are calculating, so it's velocity. Let's assume it's v1. Second mass is v2. So till nth, we are considering it vn. So this is just the velocity we are taking. So when you have the displacement, calculation of velocity is easier. What do you have to do for velocity of the center of mass? You have to differentiate the radius of center of mass over dt. So this is d over, this is m1 r1 plus m2 r2 up till mn rn. So this is over dt, and this has total mass m also, right? So when you are differentiating this, now look at this. See what we'll do. We'll take VCM is there. 1 by m can be taken common because it's a constant term. M1 will be taken outside and you'll be left with dr1 over dt plus again m2 then dr2 over dt. So till drn by dt. Okay. Now look. dr1 over dt, dr2 over dt, drn over dt. Here masses will also be there. Mn. So this is the velocity 1, this is the velocity 2, this is the velocity 3. Why? Because this is dx over dt. This is the velocity. So ultimate formula that you will get for velocity is m1 v1 plus m2 v2 plus mn vn divided by m1 plus m2. Likewise, if you are supposed to calculate the acceleration, okay, if you this was the velocity, if you're supposed to calculate the acceleration, what do you have to do? Same thing, you differentiate velocity, right? When you differentiate velocity, so this is acceleration of center of mass will be dvcm over dt. So this is now, what was vcm? So vcm is d m1 v1 plus m2 v2. So up till mn vn over dt. And yes, total mass is also there in the denominator. So here also what we'll do, we'll take out the constant term, that is 1 by m1. And for every term we have m1, then d1, dv1 over dt will be left. Plus again m2, dv2 over dt will be left. So likewise, we'll take mn out. So dvn over dt will be left. Now here again the same. You have dv1 over dt, dv2 over dt, dvnth over dt. These are what? These are accelerations. So again, the final formula of acceleration that you will get, it's m1a1 plus m2a2 plus amn an. So these are more formula which you have to remember. Now, class, the next question which I'll show you, this question is completely based upon the pulley problem. So acceleration, you have to calculate the acceleration of the center of mass. That we'll do later. Acceleration of center of mass, that we'll calculate later. But what you are going to tell me, you are going to tell me the tension and acceleration by yourself. What is the acceleration that you are getting, that you are going to tell me? What is the value of acceleration and tension? This you have to tell because we are done with the topic. And if you people will not answer in the class, then I have to plan something else for all of you. Start writing it from here. Yes, you have to find out the acceleration first. You have to find out acceleration of each of them, and that's the formula m1 a1 m2 a2. So yes, acceleration and tension you already know how to calculate. Quickly tell me, class. 1 minute I am giving, one more minute. Okay, what's the acceleration? What's the acceleration, class? You people, I think, have not understood the previous chapter too. Let's do one thing. I am also planning this thing because you people are not answering now. Initially, everybody was responsive. Now you people aren't giving responses, and your half yearlies are approaching. Let's start a revision class first. Let's stop it here. Let me complete today's class. Now I have planned this from the next class. We'll start with work, energy, and power. Proper again, work, energy, and power we do. Because in that chapter, all the portion till the fourth chapter will be done. Just leave acceleration due to gravity as G. Wherever you have to use acceleration due to gravity, just leave it as G and give me your answer in terms of G. Let's make your calculations easier. From the next class, we'll start with the entire work energy in chapter as we have done in the regular batch. And there you all have to answer. So you know which questions will be given, you know which topics will be discussed. I'll discuss the theory part again. Because in work energy power is a chapter where all the previous 4 chapters will also be covered in that. So fifth chapter I'll take, that is work energy and power, and I'll start it from the scratch the way we do in the class. Okay, this is how I'll be going. And one more revision class series are going to start where I'll be starting from motion in a straight line, but that will be in another batch. So all those who are interested and available and want to revise, 1 by 3G. 1 by 3 into G. G is in the numerator or denominator, Shaima? Just check because it's not clear over here. And all those who want to join the series, you people can. If you are weak in a particular chapter or you want a revision of a particular chapter or have been missed. So likewise, the students who are new, your backup will also be given. So there I'm starting with that. Your revision exams are also going to start. Revision test series are also going to start. But if this is the response of the class, now from the next class onwards, I'll be starting with work, energy, and power. And we'll do that chapter same, everything same in that manner. 1 or 2 questions, additional questions I can give. Only so Shaima is the person who could answer this. G by 3 is the answer. And now nobody should answer. G by 3 is there. G by 2 into 1, no. G by 3 is the answer. Now nobody should answer because I have announced the answer. Next class, work, energy, and power. Revise it and come. I'm stopping center of mass. Nobody is getting rotational motion in their exams. So rotational motion after 1 or 2 weeks we can do once the work energy in powers revision is completely done. And in that class, you all have to be responsive. If you're not attending that classes and if you're not able to respond in those classes, then I'll jump one previous chapter back. I'll start with laws of motion from the scratch. So, yes, acceleration is above, acceleration downward. It's mentioned which acceleration you have to take, positive and negative. This is downwards 5g, this is downwards 10g. Above we have tension and downwards we have tension. See, acceleration best method is that calculate the net balanced force. Calculate the net balanced force and divide it by total mass. This is also how you can get acceleration in just one step. Why am I following this? Because I am not calculating the tension. Tension is not required in this, but you know how to make the equations. You have to write T minus 5g is equal to 5a, and the second equation will be 10g minus tension is equal to 10a. So acceleration is 10g minus 5g divided by total mass is 15, 10 plus 5. So this becomes 5g divided by 10, which is equal to g by 3. Now one acceleration is already given. So take this as plus g by 3. Take the second acceleration as minus g by 3. Oh no, first is given negative. So first will be negative. Second acceleration will be positive. Right? Yeah. So now you have m1, a1, m2, a2 and values of acceleration. So what is acceleration of center of mass? It is m1, a1 plus m2, a2 divided by m1 plus m2. So this is mass first was 5 kg, acceleration is minus g by 3, plus second mass was 10 plus g by 3. Total mass is 5 plus 10, which is 15. So minus 10g by 3, this is equal to 10g by 3, 10g by 3 minus 5g by 3 divided by 15. So this is 5g by 3 into 15, right? So 5153, answer is g by 9. This is the acceleration of center of mass. Write it, class. Yes, you have to find the final velocity and then use the VCM formula. No, the velocities are already mentioned. See, this side is taken as positive, so this is positive. This side is taken as negative. What is VCM's formula? M1 V1 plus M2 V2 divided by M1 plus M2. First mass is 2 kg. Velocity is 5 meter per second. M2 is 5 kg, but velocity is 2 meter per second. We are going to take it as minus 2 meter per second because it's a vector and we have to keep the direction in mind. Shaima's answer is correct. It will be 0, not 2.8 Zeneb. See how? 2 into 5, this is also 5 into minus 2. So they'll be cancelled. The data is just exchanged over here. So 2 into 5 plus 5 into minus 2 divided by 5 plus 2 straight away. This will be cancelled. 10 minus 10 will be 0. So answer will be 0. Write it. See, we have discussed the concept of the internal forces and external forces. So just a revision of that. Suppose, let's take an example. Sun is there in the center and around the sun, Earth is present. Now, this is our system right now. So the system is Sun plus Earth. Why this is the system? Because this is the area under observation right now. Any other thing which is present apart from this sphere, so it will be considered outside. That is, that will be a part of surrounding. So system plus the surrounding will make up the universe. So this is the system and this is the surrounding, anything which is present apart from our system. It's not necessary that we take the system only, any system which is present. Means the area under observation. Now look at this example. Suppose sun and earth exert gravitational forces on each other. Gravitational forces also, gravitational potential energy also. Moreover, gravitational forces. We are talking about forces current. So these forces, gravitational forces, are considered as the internal forces of the system. Now there's another planet outside, let's say Mars. Now this will also be having some gravitational forces of attraction with the sun. Now since this is outside our system, because we have not considered it under our system. If our system was sun plus earth plus Mars, then this would also have been our internal force. Now this is our external force. Now suppose this, the gravitational force of earth and sun, they cancel each other and we get the net force as mu. So the system which we are discussing, this system will be called as an isolated system. Now this concept of isolated system is helpful. Here the momentum is also conserved. That is, net momentum is C. And we'll be using this concept to find out the net center of mass for a system which is given. So internal forces, system of particles, they cannot affect the center of mass. External forces, they affect these are also system of particles, they can affect the center of mass. Because internal forces are part of system, the center of mass is associated with the internal force itself. But if the external force, we have the external force that is being changed, center of mass can easily shift because it has the ability to shift the center of mass. So acceleration of center of mass is present. Now you use Newton's second law, F is equal to ma. So what will be the formula of force on the center of mass? M into acceleration of center of mass. So what you do, you calculate the center of acceleration of the center of mass and you calculate the total mass of the. So you calculate the total force of the system by multiplying the total mass into acceleration of center of mass. This way you will be having the force also. Write down all these things, make a note point and write it.
Ma'am, can you please scroll down?
Yes, class. All those who have completed, you can leave. Now in the next class, I'll start again with work.